Hey, so this is going to be a short demonstration of how to use MATLAB to approximate the value out of a vector that is not currently existing, right? So in this example, this is a time vector from 0 to 10 in increments of 0.25, right? Then we are using this to form a function, a function y of t, which is t squared, right? And anyways, this is a dot product. So we're trying to square each element inside the time vector to store in y of t, right? So maybe a question is asked you that find the time at which the square function, which is y of t, gave us what 6.3, right? So by default, the way to do it is to just do find y of t being equal to that. And then this will give you the position. I just put IND for index, right? So let's run this section of code and see. And let's see if there was any y of t that was 6.3 from the time vector we're given. So I'll just run section and right click and then I'll choose run section. And then in our command window, we are seeing 1 by 0 array. That's very interesting. Okay. So that means we don't have any y of t being equal to 6.3 inside this vector, right? But what if we wanted to actually know what it is? Then that's where we need approximation, right? So how to do it? Let me just show you a very simple illustration. Um, so let me see if it's possible to switch tabs. Okay. So let me go to Microsoft and Edge. Where is the Microsoft Edge? Okay. So this number line over here is illustrating what is happening, right? So the blue that you are seeing here are the actual function values inside the y of t, right? But this black dot is not any of the blues, but it's closest to two of the blues, right? And this is what I'm going to use to approximate. So the point is, we want to look on the choose a range, I mean, choose a range that will include this black gentleman and find where inside this range has the closest value to the actual value I'm looking for. So let me show you how what I'm talking about in program, right? So I go to the next section, right? Here, so let's say we are going to choose 6.3 is our focus, right? So you subtract some deviation from it. That means something below it right away to, inside the t square, right? The y of t, right? Let me just retype this. So this is just y of t. So y of t. So you're trying to find a range where y of t is between 6.3 minus that up to 6.3 plus some deviation. So that means this deviation you do here and this one here don't necessarily need to be the same, but you can make them the same if it will help, right? So for the first time, so this is how I write it in program, right? So I take y of t greater than or equal to, then the first delta x one for me, because that's the minus, right? I use 0.02. And the second one I do this greater than or equal to. You can actually just greater than or less than, but I want to use the equal to. So that if it includes it, so that'll be fine. Then I've used this range. Okay. So let me just use maybe 32 or something. Let me see. So when I do this, let me try and see if there'll be a value in between. Let me just look at two. Okay, good. So let's do this and let's see if there's a value above, between this range that had the closest value that's of the 6.3 you can find in this range. So let's monitor just the IND value. So I'm going to run this section and then let me see. So after running it, um, oh, let me see. So run section. Oh, okay. Interesting. So let me do Control C and then let me try again. Okay. So, oh yeah. Look at the mistake I've done. Interesting. Okay. So I'm going to just run section. Okay. So you are seeing that the IND is given at 1.0. That means the range I chose is not good, right? So this is quite of a manual process. So you just choose another range. So let me go maybe 0.02 and let me make this 0.2 and then let's see. So I'm going to rerun it. So run section again. Okay, it looks like I'm finding some value, right? Okay, so this time round, there was a value for the index, right? And then the approximated value was 6.25, right? Which is very close to 6.3. And then the actual value, I'm telling you, that's the time that's corresponded to this was 2.5 seconds. But now I would like you to just look at something. So to choose the range, it's good to know the actual value. So let me find the square root um of 6.3, 6.3. And then let's see. So you use that to guide which range to choose, right? The answer was 2.509. So that means if you are choosing the range and you even you happen to get an answer and the answer is not similar to this, you know that the range you chose is not right. So this because our answer was 2.50 and the expected was 2.509, which is very similar. That means I can approximate that the time at 6.3 would be about 2.5 seconds. So yeah, that's a very simple demonstration of how to use approximation in MATLAB. So just use the greater than or equal to symbol and then do some deviations from the actual place and use that to determine the best fit for the answer. Yeah. So thank you. And then you can, rewatch and then whatever I want to do with the information. Yeah.